Title of the first section today is Solving Systems. In three variables. The section will have equations that have three variables, and we'll solve for all three. First equation is x plus 2y plus z equals 10. And second equation, 2x minus y plus 3z equals negative 5. And last equation, 2y equals 8. So three equations, three variables. We'll figure out what x is, what y is, and what z is. Looking at the equations, the third equation we can solve by dividing by 2. And our first answer, y would equal 4. Once we know one variable, we can plug it back into each of the other equations. So the first equation would be x plus 2y, or 2 times 4, plus z equals 10. Solving this one, we'll have x plus 8 plus z equals 10. And subtracting 8 on both sides, we'll have x plus z equals 2. Looking at the second equation, if we rewrite that one, we'll have 2x minus y, but y is equal to 4. So 2x minus 4 plus 3z equals negative 5. Simplifying, add 4 to both sides, and we'll have 2x plus 3z equals negative 1. After solving for y and plugging it back into the first two equations, we have x plus z equals 2 and 2x plus 3z equals negative 1. If we take this first equation and multiply by 2, the 2x will match up with the other 2x, and we'll be able to eliminate them using elimination. So taking the equation x plus z equals 2, we'll multiply by 2, which will be 2x plus 2z equals 4. And again, using elimination, we can subtract these two equations. So 2x minus 2x would cancel. 3z minus 2z would be 1z, or just z. And negative 1 minus 4 would be negative 5. So our second answer, z equals negative 5. So we have y equals 4 from the original problem, z equals negative 5. Once you have two variables, you can plug it back into either the first equations to solve for x. If we take the first equation, which was x plus 2y, but instead of y we'll put in 4, and plus z, but instead of z we'll use a negative 5, and equals 10. Solving from here, x plus 8 minus 5 equals 10, or 8 minus 5 would be x plus 3 equals 10, and subtracting 3 on both sides, we'll get our final answer, x equals 7. So we have three answers. All three answers you can write as a single point, which will be x, which is 7, y, which is 4, and z, which is negative 5. So our final answer would be 7, 4, and negative 5. Title of the last section today is More 3-Variable Equations. First equation is 2x plus y plus z equals 14, and negative x minus 3y plus 2z equals negative 2, and last equation 4x minus 6y plus 3z equals negative 5. To solve these equations, you want to first eliminate one variable. For example, if we take the second equation, which has negative x, we can multiply that by 4 so we can eliminate the x's. Multiplying by 4, we'll have negative 4x, and multiplying each number in each term by 4, we'll have negative 12y plus 8z equals negative 8. Combining this equation with the third equation, we can add those together to cancel out the x's. Negative 6 plus negative 12y will be negative 18y. 3z plus 8z would be 11z. And negative 5 plus a negative 8 would be negative 13. Now we have one equation that has only two variables, y and z. Now what we can do is go back and use the very first equation, which we did not use, and use either of the other two equations to eliminate that same variable, which will eliminate x. For example, if we rewrite the first equation, 2x plus y plus z equals 14, and then we can take the second equation. Instead of multiplying by 4 though, we can multiply by 2, so the x's would cancel. Multiplying by 2, it would be negative 2x, 2 times a negative 3y, negative 6y, 2 times a positive 2z would be plus 4z, and 2 times a negative 2 would be negative 4. Combining these two equations, we can add these together to cancel out the x's. Y plus a negative 6y would be negative 5y. Z plus 4z would be 5z. And 14 plus a negative 4 would be 10. And again, we have another equation with just two variables, y and z. Once we have two equations with two variables and the same two variables, y and z, we can combine these two to eliminate either the y's or the z's and simplify from there. If we take the equation that we had before with x and y, or with y and z, we can multiply negative 18 by 5. That way the y's will match up after we multiply the second equation. 5 times negative 18 would be negative 90y. 5 times 11 would be 55z. And 5 times a negative 13 would be negative 65. Multiplying the last equation we had, we can multiply this equation by 18. That way again the y's will match up. 18 times a negative 5 would be negative 90y. 18 times a positive 5 would be 90z. And 18 times 10 would be 180. These equations again, the y's have the same coefficients. We can subtract these. So negative 90 minus a negative 90 would cancel out the y's. 55 minus 90 would be negative 35z. And negative 65 minus 180 would be negative 245. after eliminating the x's and now the y's, we're left with just z, and we can divide by negative 35 to get our first answer of z equals 7. Continuing this question, once you find one variable, you can plug it back into any other equation to solve for the others. An easy equation to use would be one that has z and one other variable. For example, the last equation we had with y and z would be negative 5y plus 5z. But instead of z, we can put a 7 in, and equals 10. Solving from here, negative 5y plus 35 equals 10. Subtracting 35 on both sides, negative 5y equals negative 25. Dividing by negative 5, and we'll have our second answer, y equals positive 5. Once we have both two variables, z and y, we can plug them into any other equation to solve for x. If we take the very first equation in the original problem, which was 2x plus y, but we can substitute a 5, plus z, which would be 7, and equals 14. Solving from here, 2x plus 12 equals 14. Minusing the 12 on both sides, 2x equals 2, and dividing, we'll have x equals 1. So we have three answers for the question: x equals 1, y equals 5, and z equals 7. And again, you can write this as a point x comma y comma z, which would be 1 comma 5 comma 7.